Paano nga ba natin i-apply yung mga limit theorems na napag-aralan natin dun sa previous na video natin? So sa video lesson na to, pag-aralan natin kung paano natin i-apply yung mga limit theorems sa pag-evaluate ng limits of polynomials, rational, and radical functions. So before we start, let's hit the intro. Para sa objective natin ngayong araw, so at the end of this video lessons, you should be able to apply the limit laws in evaluating the limit of algebraic functions like polynomials, rational, and radical functions. So, unang example natin, we have the limit of 2x plus 1 as x approaches 1. Since yung function natin ay merong 2x at 1 at pinaghihiwalay ng addition operation. So, since meron tayong addition operation sa gitna ng 2x at 1, pwede nating i-apply yung addition theorem. So, para natin i-apply. So, we have the limit of 2x as x approaches 1 plus the limit of 1 as x approaches 1. So, ang ginawa lang natin dito ay pinaghiwalay lang natin yung individual limit of functions nila. So, para sa second step, we have for the limit of 2x, pwede natin i-apply dito ang constant multiple. So, pwede natin ilabas si 2 doon sa function. So, we have 2 times the limit of x as x approaches 1 plus the limit of 1 as x approaches 1. Next, evaluate na natin yung limit. So, we have 2 times the limit of x as x approaches 1 is simply substitute na natin yung value ng c doon sa x natin, which is 1 plus the limit of 1 as x approaches 1. So, the limit of a constant is the constant itself. So, we have 1. So, this is equals to 2 plus 1 equal 3. So, para sa second example natin, we have 2x raised to 3 minus 4x squared plus 1 as x approaches negative 1. Since dito sa function natin, may makikita tayong subtraction and addition operation. So, ang gagawin natin ay i-apply lang natin yung addition and subtraction theorem. So, we have the limit of 2x cubed as x approaches negative 1 minus the limit of 4x squared as x approaches negative 1 plus the limit of 1 as x approaches negative 1. So basically, ang ginawa lang natin dito ay pinaghiwalay natin yung mga individual limit of functions nila. So for the second step, we have here the limit of 2x cubed and the limit of 4x squared as x approaches negative 1. So this is constant multiple theorem. So we have, ilalabas lang natin yung mga constant nila. So we have 2 times the limit of x cubed as x approaches negative 1 minus 4 times the limit of x squared as x approaches negative 1 plus the limit of 1 as x approaches negative 1. So, ang next step natin ay, since meron tayong power doon sa dalawang x natin, so pwede natin i-apply ang power theorem. So, we have 2 times negative 1 cubed minus 4 times negative 1 squared plus the limit of 1 as x approaches negative 1 is, of course, this is the limit of a constant. So, we have 1. So, this is equal to 2 times negative 1 cube. We have negative 1 minus 4 times negative 1 squared is 1 plus 1. Simplify. We have negative 2 minus 4 plus 1. And this is equals negative 5. For our third example, we have the limit of 3x raised to 4 minus 2x minus 1 as x approaches 0. Since dito sa function natin ay mayroon tayong subtraction operation, pwede natin gamitin yung addition and subtraction theorem. So, paghiwalay natin yung mga individual limit of functions nila. So, we have the limit of 3x raised to 4 as x approaches 0 minus the limit of 2x as x approaches 0 minus the limit of 1 as x approaches 0. Next is gagamitan natin ng constant multiple dito sa 3x raised to 4 and 2x. So we have 3 times the limit of x raised to 4 as x approaches 0 minus 2 times the limit of x as x approaches 0 minus the limit of 1 as x approaches 0. So again, power theorem kasi meron tayong raised to 4 dito. And dito naman ay substitution theorem. And dito is constant theorem. So we have 3 times 0 raised to 4 minus 2 times the limit of x as x approaches 0 is simply 0. And then the limit of 1 as x approaches 0 is 1 by constant theorem. So this is equals 0 minus 0 minus 1. And our limit is negative 1. So class, sa pag-evaluate ng limit ng ating polynomial at rational functions, merong dalawang theorems para mapadali ang ating pag-compute ng limits. So the first is to we let f of x and g of x, and these are polynomial function. We have h of x is a rational function. If c is a real number, then the limit of f of x as x approaches c is equal to f of c. And then the limit of h of x as x approaches c equals to the limit of f of x all over g of x as x approaches c. And then this is equal to f of c all over g of c. So sa mga susunod na isosolve nating problem, i-apply natin yung dalawang theorems na ito. So for this fourth example, we have the limit of 2x cubed minus 4x squared plus 1 as x approaches negative 1. So i-apply natin yung dalawang theorems na napag-aralan natin a while ago. So since our function is a polynomial, sabi ng first theorem na if the limit of f of x as x approaches C, where C is a real number, then this is equal to f of C. Paano natin gagawin? So we have the limit of 2x cubed minus 4x squared plus 1 as x approaches negative 1. Para may apply natin yung theorem na ito, we simply substitute the value of negative 1 sa mga x natin. So we have f of negative 1 equals 2 times negative 1 cubed minus 4 times negative 1 squared plus 1. This is equal to negative 1 cube is negative 1. So we have 2 minus or 2 times negative 1 minus 4 times negative 1 squared is 1 plus 1. Simplify. So we have negative 2 minus 4 plus 1. And this equals to negative 5. So, lagi yung tatandaan, class, ang sinasabi ng theorem na to ay if C is a real number and then pwede natin siyang i-substitute yung value ng C doon sa x natin. So, for our next example, we have the limit of irrational functions. We have the limit of x squared minus 3x all over 2x squared minus 5x minus 3 as x approaches negative 3. So, sabi doon sa theorem natin, kung mayroon tayong limit ng h of c or h of x, ng h of x na to ay rational functions as x approaches c. And c is a real number, so we have the limit of f of x as x, or the limit of f of x all over g of x as x approaches c. Then, we have f of c all over g of c. Paano natin i-apply ang equation or ang theorem na to? We simply plug in our c here, which is 3 in our equation or yung mga x natin. So, we have 3 raised to 2 minus 3 times 3 all over 2 times 3 squared minus 5x minus 3. And this is equal to 9 minus 9 all over 18 minus yung x natin dito ay 3 minus 15 minus 3. Of course, we have negative 18. And this is equal to 0 over 0, which is, ang sagot natin ay undefined. Undefined yung sagot natin. Undefined. Hindi tayo pwedeng magkaroon ng limit na which is undefined. So, anong gagawin natin? Ang gagawin natin, class, ay i-factor out natin ang numerator at ang denominator. So, we have the limit of x times x minus 3 all over, factorable naman yung denominator, which is ang factor niya ay x minus 3 times 2x plus 1 as x approaches 3. Next step is to simplify. So we have, makakancel yung x minus 3 natin. Ang may iwan dito ay the limit of x all over 2x plus 1 as x approaches 3. Yan. Pwede nating substitute. So we have 3 all over 2 times 3 plus 1. And this is equal to 3 over 6 plus 1. Or, have 3 over 7. Ito ang limit niya. So we have our last example. So we have the limit of square root of x plus 2 minus 1 all over x plus 1. So let's try to solve for f of negative 1. So we simply substitute negative 1 sa mga x natin. So this is equal to the square root of negative 1 plus 2 minus 1 all over negative 1 plus 1. So very obvious, 0 na yung denominator natin. Pero tuloy palin natin. Yan. So we have the square root of 1 minus 1 all over 1, negative 1 plus 1. So this is equal to, so square root of 1 is 1 minus 1, 0. All over negative 1 plus 1 is 0. So mayroon na naman tayong undefined na sagot, which is hindi pwede sa ating limit. So ano ang gagawin natin? Since mayroon tayong radical dun sa numerator natin, pwede tayong mag-multiply ng 1 dun sa numerator. Ang 1 na yon ay yung conjugate ng square root of x plus 2 minus 1. Ano yung conjugate na yon? So we have square root of x plus 2 plus 1. Ito yung conjugate natin. 1 na ba yan? Paano magiging 1 ito? Magiging 1 siya kapag dinivide ulit natin siya dun sa conjugate niya. So we have x plus 2 plus 1. So, pwede na tayong mag-start sa pag-evaluate ng limit. So we have the limit of x plus 2 minus 1 all over x plus 1 as x approaches negative 1. Multiply natin yung 1, which is yung conjugate natin. So we have x plus 2 plus 1 all over square root of x plus 2 plus 1. So multiply na natin. So we have the limit of, so x plus square root of x plus 2 times the square root of x plus 2 is simply x plus 2. X plus 2 times 1, of course, we have plus x plus 2. So, negative 1 times x plus 2 is negative x plus 2. Negative 1 plus times positive 1 is negative 1. All over x plus 1 times x plus 2 plus 1. Remember, class, nakalabas yung plus 1 natin. Nakalabas siya. Hindi siya kasama sa radical sign. So, simplify and this is approaching negative 1. Again, simplify natin. Magka-cancel out to kasi 0 na siya. And then, we have the limit of x plus 2 minus 1 all over x plus 1 times x plus 2 plus 1 as x approaches negative 1. Again, we have, simplify ulit natin, the limit of 2 minus 1 is 1, so we have x plus 1 all over x plus 1 times square root of x plus 2 plus 1 as x approaches negative 1. Magka-cancel out yung x plus 1 sa numerator at denominator. So, ang may iwan na lang ay the limit of 1 all over square root of x plus 2 plus 1 as x approaches negative 1. So, pwede na nating substitute yung negative 1. So, we have f of negative 1 equals 1 all over square root of negative 1 plus 2 plus 1. And this is equal to 1 all over square root of 1 plus 1, and therefore we have f of negative 1 equals 1 over 2. Yan. 1/2 ang sagot. So that's it. Diyan nagtatapos ang ating video. So kung may natutunan ka sa aking video, just hit the like and subscribe button para lagi kayong updated sa aking basic calculus series at iba pang mga tutorials. So see you on the next video.